Hey everybody, it's Dr. J, and today we're talking about entropy. Let's talk chemistry. Alright, so we're still talking about entropy. In this case, how do we calculate the entropies of reactions? So this is what I was mentioning before, right? If you understand what state functions are, we understand that state functions only care about the initial and the final conditions, right? So as I mentioned before with enthalpy, once again, I highly recommend to go back to the previous videos about enthalpy and my General Chemistry 1 playlist, right? Or if you go to what do you know, right? We got a couple of different problems in there too. But essentially, it's just like enthalpy, right? So in this case, instead of using those enthalpies, we're just going to be using the entropies, which are going to be given to us. Because thanks to all the chemists that did it for us before, we already know the values. So essentially, we're just going to do our sum of our products minus the sum of our reactants. The exact same thing as our enthalpies. Literally the exact same thing. The only difference is that instead of using enthalpy, we're just now using entropy. So what does that look like? Well, essentially, let's say we got our example here, magnesium reacting with carbon dioxide to produce magnesium oxide and carbon, right? So what are we going to do here? We're going to take those entropy values that are going to be given to us, right? So we look those up. It's 32, 215, 27, and 6, right? So what do we do for our equation? Well, it's just products minus reactants, right? Using the same coefficients. So that's just going to be 2 times 27 for my MgO, right? Because this is my value, my entropy for this particular compound. So 2 times 27 plus, right, because it's the sum of my product, so plus this 1 times 6 for my product side. Now we're going to subtract that from our reactants. In this case, our reactants are going to be 2 times my magnesium. In this case, magnesium is going to be 32, okay? And then we have our carbon dioxide. In this case, carbon dioxide is going to be 215, 1. So we're going to do products minus reactants in this case, and then we'll add them all up together. In this case, products, we're going to get 60 minus our reactants. In this case, is going to be 279. So that's going to see an entropy of negative 219 joules over Kelvin times moles. So we get our final answer, right? Negative 219 joules over Kelvin mole. So this negative value is telling me that my entropy is decreasing. If our entropy is decreasing, we're becoming more ordered, right? And that makes sense, right? In this case, right, we had this gas here, but we went to 2 solids, right? So our reaction became more ordered. And this is how we're going to calculate the entropies of reaction. Okay, so everybody, that's entropy summed up all in one. Okay, take a look at this video. Definitely take some notes, and I will see you guys next time.